Yeah. Hope you are able to see my screen. Hello. Yeah.
Yes, sir, we can see.
Yeah. So, so let us today discuss about this downlink transport channel processing. Okay. So it is basically uh, deals with the physical layer processing. Okay. So hope you will be able to recall your basics and whatever the topics which we have discussed in the previous classes. So just I wanted any one of you, is it possible to say what is the purpose of transport channels before I take up this processing? Yes, be fast, my dear students. So yes, I'm asking the purpose of transport channels, what it does. Yes, I think you can't say. Say yes or no. You want to say yes or no also, I need to wait so much of time. You people don't want any interactive type of exchanging knowledge. Only you want me to say from my end. Whether you listen, don't listen, God only knows, right? Just I'm asking, what is the purpose of the transport channels, which you have discussed in the 2-3 classes? What are the different types of traffic transport channels and all? But I'm not asking that. I'm just asking the purpose of transport channels.
Sir, it is necessary so that
Yeah.
we can get to know what type of data, how it is transferred to the higher layers, and how data and signaling messages are carried on to the transport layers between the between the different layers of LTE channels.
Okay. Okay. To certain extent, you are right. Fine. Anybody else? When I'm asking only about transport channel, so you should know it is the mm, these are the channels which will provide services to what layer, from what layer to what layer. That can,
Sir, it
uh,
type of physical layer, sir, like the transport is between the MAC and the physical layer.
yeah, very good. So to add on to that, what I can say is the transport channels are used by the physical layer to offer services to the MAC layer. Okay, so the transport channel is characterized by how and with what characteristics the data is transferred over the radio interface. So this is very, very important to say. Okay, transport channel is characterized by what, how, and with what characteristics data is transferred over the radio interface. So here, what I mean to say, the characteristics of the data means what is the type of channel coding scheme used. Okay, sorry, what is the type of channel coding scheme used, and what is the type of modulation scheme used, and what is the antenna mapping. So these are the key things which will characterize the characteristics of the data. Okay, so that is how we say about the transport channel. Hope I am clear with this. I repeat once again, I said the transport channels are used by the physical layer to offer services to the MAC layer. Okay, that's the first point. The next thing is the transport channel is characterized by how and with what characteristics data is transferred over the radio interface. Okay, over the radio interface. Here, the characteristics of data to say that what type of channel coding scheme is used and what is the type of modulation used Okay, and what is the type of antenna mapping is done. So that is all about the transport channel, what I can say. Fine. So with that basic understanding, I already discussed what are the downlink and uplink transport channels. So any one of you, is it possible to just name the types of downlink transport channels quickly? Yes, just I'm asking you to name just the types of downlink transport channels.
So paging channel, broadcast channel, and multicast channel.
Yeah, correct. What you are saying is correct. Is it possible to add few more? Yeah, one what you said is paging channel. Second one is the broadcast channel. Then two more are there in the downlink.
Multicast.
Yeah, multicast channel. Then downlink shared channel. What you say DLSCH. Okay, so these comes under downlink transport channels. And as far as uplink transport channels is concerned, I said about two types. Is it possible to say any one of you quickly? Uplink transport channels. So at least name I am asking, not the functionality. Okay, I think you should be able to tell with the functionality. Yes, uplink transport channels. Only two are there. Very easy to remember. Uplink transport channel. Yes, nobody can say. See, one is uplink shared channel. Second one is random access channel. Okay, so these are the two uplink transport channels. Okay, having this idea in mind or knowledge in mind, so let us try to understand how this downlink transport channel processing is done. So actually, this processing of downlink transport channel has several steps. Okay, so basically we divide this into two categories. One is the channel coding process, and another one is modulation processing. Okay, broadly to say, under channel coding processing, there are various steps. We'll have a step-by-step discussion about that, even under the modulation processing also. Okay, so as I said already, the physical layer provides the services to the MAC layer through this transport channels, right? And what I said is the data and control streams coming from the MAC layer are organized in the form of the transport blocks. Okay, so you should visualize whatever the data and control information comes from the MAC layer, that will be organized in the form of what? Transport block. Okay, it will be transport channel carries transport blocks. So you should start thinking what should be the size of the transport block. Okay, is it fixed or is it variable? Fine. So what the transport block, I hope you should be able to find out that. Okay, I'm not giving at this time. At present, what is the size of the transport block? I will leave it to you people. I think I expect you people to search and say in the next class transport block size. Fine. Then I said that each transport block is what? It is a group of resource blocks, right? With common modulation and coding scheme. So by this time, I hope you know what is a resource block. I said it is a group of resource block. Okay, the transport block is what? Is a group of resource block with common modulation and coding scheme. Okay, so as I said, in the downlink physical layer processing, I said it has two processing mainly. One is channel coding, and second one is the modulation. Okay, so this modulation will map the transport block to specific physical time frequency resources, and this channel coding involves mapping the incoming transport block from the MAC layer to into different code words. Okay, the channel coding will do that. Okay, it will be mapping the incoming transport blocks from the MAC layer into different code words. Fine. So I think we will be able to appreciate this functionality if I take an example. So before that, let me say an overview of this downlink transport channel processing. So these are all the different blocks which are involved under the downlink transport channel processing. Okay. So as I said, broadly we say channel coding processing, and another one is modulation processing. Okay. So this channel coding processing involves these steps. Yes, any one of you, is it possible to just read and say, or each one of you can read one block? Yeah, that is better, I think, so that 5 people can unmute and talk. Yeah, come on, quickly. Yes, my dear students, I am just asking you people to read the name of the block which is written in the PPT. Even that you can't do? Yes, hello.
CRC addition one, sir. Block.
Yeah, first block is the CRC addition. Fine. So
Yes.
for that input is what? The transport blocks.
Transport
Right?
blocks.
Yeah, transport blocks, as I said, it comes from the MAC layer, right? So from the MAC layer, the data, okay, and as well as control information will come as it in the form of transport blocks. Okay, for that transport block, CRC will be added. You know what is the purpose of CRC and what it is. Yes, other people can say what is CRC, at least expansion. Other people,
Cyclic redundancy check, sir.
yeah, it is a cyclic redundancy check, right? So maybe knowing the purpose, what is the purpose of that CRC? Yeah, yes, other people. So transport block, for that CRC will be added for that block. Let us see what is the size of the CRC we are going to add to the transport block. Okay. Then what is the next block?
Code block segmentation.
Very good. So next block is the code block segmentation. Okay. Then next block. Yes, be fast. Next block. Just I'm asking you people to read.
Channel coding.
Channel coding. Okay. Then next is what?
Rate matching.
Rate matching. Okay. The next. Yes, next block. Reading difficulty.
Code block concatenation.
Yeah, code block concatenation, right? So these are all the different blocks. Okay, so every block has its own functionality. Okay, so output of the channel coding processing will be in the form of what? Code words, I said, right? So that is what is written here, code words. So these things should come into your mind. Channel coding processing means it involves CRC addition, code block segmentation, channel coding. The moment I say channel coding, you should be able to visualize, okay, what are the different types of channel coding techniques you have studied and what technique is used where. Then rate matching, of course, this may be new to for you people. I will tell what is the function of that rate matching. Then code block concatenation. Okay, so how many blocks are there? Totally 5 blocks are there. So each block, as I said, will do its function in a very unique way. Let us try to understand what is the output of each block and how does it improves or helps in shaping the information. Okay, so this is all about channel coding processing. I said the second one is the modulation processing, right? So together is known as the transport channel processing. So this is about the downlink, what I'm saying. Okay, so modulation processing consists of what? Yes, other people can just read now. Yes, other people can read. Hello. Yes, I think at least 5 people have read the above five blocks. Why is it not possible to read? Some more blocks are there in the downstream, that is about the modulation processing. So other 5 people can talk now. So I find, I think 15 people are there in the class today as of now. Out of 15, 5 have spoken. So another 10 people have the opportunity to unmute and say. Yeah, be fast. Yes, be fast to read.
Scrambler modulation mapper.
Yeah, okay, in the modulation processing, the first block is what? Scrambling. Okay, means whatever the output of the channel coding processing is coming, that will be in the form of code words, that will be scrambled. Okay, hope you know the meaning of scrambling. We'll see when we are discussing with example. Okay, yeah, next, what is the next block after scrambling?
Modulation mapper.
Modulation mapper. Fine, let us see what is that modulation mapper. Then then what is the next block? Yes, next block, just I'm asking to read.
Layer mapper.
Layer mapper, right? So of course you may be understanding here, since it is about downlink, no? So from the base station, so there will be multiple antennas will be there, right? So that is why it is written in parallel. Scrambling, it can have n number of that blocks. Okay, parallel. Then modulation mapper, then layer mapper. Okay, then output of layer mapper is given to what? Yes, just name the block.
Pre-coding.
Pre-coding, right? So okay, after layer mapping, pre-coding is done. So output of the pre-coding is given to what? Yes, others, what
Resource
is
mapping.
this? Resource mapping, right? So we have, in brief, I think I have discussed how do we do the resource allocation. So what are the different types of resource allocation? So that concept should be visualized here. Okay, I hope you all remembered resource allocation. I told about type 0, type 1, and type 2, right? Both in downlink and as well as uplink. And again, in that, what I said, 2 types, right? Hope remembered how the resource allocation is done. So that is a resource mapping. Then, yes, what is the next block after resource mapping?
OFDM signal generation.
Yeah, OFDM signal generation, right? Then that OFDM signal generation will be given to the antenna ports. Okay, so there are different ports. So that will be given to that. So these are all the different blocks which are involved in the downlink transport channel processing. Okay, so since it is a block diagram approach, yes, of course, each block, as I said, its own functionality and depth of understanding. But if they ask in exam, at least maybe as a beginning, you should be able to reproduce all these blocks. So broadly, you should have in your mind 2 things. One is channel coding processing, another is the modulation processing. So under channel coding processing, what are the different steps involved? Okay, I said that there are 5 blocks, right? Starting from adding CRC addition to code block segmentation, channel coding, rate matching, then code block concatenation. Then output of that channel coding processing will be in the form of code words. That will be, those code words will be given to what? Scrambling, modulation mapper, layer mapper, pre-coding, resource mapping, then OFDM signal will be generated. Then that will be fed to the antenna ports. So let us try to understand each step. Okay, so I will skip this. Of course, this is all the same thing only. Okay, just how the channel coding processing, what I said, no, the 5 different blocks. So that is here reproduced to say how the functionality of each is done. Okay, so transport block will be having some size. Let us assume that some number of bits. Okay, the transport block will have some number of bits, right? So for that, the CRC bits are added. So for this transport block, that is known as CRC addition. Okay, that is cyclic redundancy check, right? The purpose of this is to what? Any one of you can say what CRC will have? Are you aware of the functionality of CRC? Yes, quickly, any one of you, is it possible to say from your end? CRC, cyclic redundancy check. Yes, you might have very much studied in your CCN now. Can't say the functionality of CRC. Even you might have calculated how do we find CRC, what is a polynomial and other things. No idea? Yes, my dear students, please be fast to say whether you have idea or not. Yes, nobody is talking. Why? What happened? Cyclic redundancy check, I'm saying. Is it visible, my slide? Hello?
Yes, sir. So it provides error detections.
Yeah, the purpose of CRC was, as rightly pointed out by Sonali, the purpose is to error detection, right? So it may be 8 bits or 16 bit or 24 bit. Okay, usually here it is of 24 bits. Okay, so that we say CRC attachment. For the transport block, the CRC has been added. Then the next block is what? Code block segmentation. No? So depending upon the size of this, again, this will be divided into few more number of blocks along with the CRC addition. So that is why it is written code block 1 along with CRC, code block 2, and so on up to code block C with CRC. Okay, so that is what the code block segmentation. Let me say what is the purpose, why we do this. So if the size is more than certain value, okay, if the transport block along the CRC exceeds certain value, then that will be broken up into segmentation. Okay, after doing that, okay, so we do the channel coding. Either it may be turbo coding or convolutional coding with some rate. It may be 1/3 or 2/3 and so on. Okay, that is the next process. After that, the rate matching. Okay, I will come back to this rate matching. I think with the example you will be able to understand. Then the code block concatenation is done. Means when I do this channel coding, no, so that how incoming serial data is converted into parallel data, then that parallel to serial, like that it happens, that process. So you will be able to get that idea with the example. Okay, so just you should have in your mind. So these are the different blocks involved in the channel coding processing. Okay, so just let me go. I think I need not say, already I told about this, what I said. Channel coding, right? For the downlink is the combination of what? Error detection, error correction, rate matching, interleaving, transport channel control information mapping onto the physical channels. That's what. So this channel coding provides an error control mechanism for data transmission using FEC codes, that is forward error correction codes, and as well as the error detection based on the CRC codes. Okay, so FEC code will do the error correction, and CRC is able to do error detection. So I hope that clarity you may be having. Then you all know in the downlink the shared channels, right, we use. So the error control mechanism is coupled with the retransmission mechanism. What is that retransmission mechanism? Is what this is what hybrid ARQ protocol. Okay, so this combined error control and retransmission mechanism improves the link reliability, okay, in the fading channels. So to improve the link reliability, we do this. Then the coding rate at the channel encoder is fixed, and different effective coding rates for the whole transport blocks are achieved by repetition or puncturing during the rate matching procedure. So yeah, to say about the CRC addition to the transport block as a first step, what I said, CRC is used to provide error detection, I said, right, on the transport block. So this CRC will be generating the parity bits by cyclic generated polynomials, right? So which will added at the end of the transport block. So the number of parity bits can take the values of this 8, 16 or 24, and in this the 24-bit CRC is the baseline for the downlink shared channels. Okay, so the length of the CRC is 24 bits. What I wanted to say here is, so now let us try to understand about that channel coding processing. Okay, so of course maybe for better understanding I have taken it from a different source. Hope you all will be able to understand that. So this is how we say, see, incoming data will come from the MAC layer, right? So I am representing that in what A0, A1 and so on. Okay, so we add CRC bits to the transport blocks, right? To the incoming series of bit stream, we are adding CRC bits. Then I represent output of the transport block with the CRC addition as B0, B1, B2. Okay, so that is the input of the what? Code block segmentation. Okay, code block segmentation with CRC attachment, right? So output of that, I will be denoting it as CR0, CR1 and so on, just for understanding. So then channel coding, right? So channel coding, I said either it may be turbo coding or convolutional coding, what we use. So just try to understand the notation at what I denote at each of the block input and output. Okay, fine. So then you will be able to understand the process. Okay, just yeah. So as I said, as a first step, we add 24 bits of CRC, right, to the transport block. So that is what is written here, A0, A1 and so on. So for this, this is the transport block, what I get from the MAC layer. For this, the 24-bit CRC is added. Yes, able to understand this? After adding CRC bits, I denote output of the transport block with CRC addition as what? B0, B1 and so on up to BB minus 1. Okay, so this is what the transport block, and this one is the CRC bits, and the number of CRC bits will be equal to what? 24 bits. So I denote this as B. So this will be equal to what? A plus 24, I say. What is that A? A is the transport block size. Okay, in simple mathematics, you take the transport block size will be denoted as capital A. Okay, for that I said we are adding a CRC bit of 24 bits. So I call that as output of the transport block with CRC as B, which is equal to A plus 24. Yes, hope this point is clear. Yes, my dear students, this point is clear. In a simple language, I am saying B is what? Output of the transport block with CRC attachment. So B is equal to what I can write? A plus 24. What is A? A is the size of the transport block. For that, 24 bit CRC is added. So I write B is equal to A plus 24. Yes, is this clear? I am asking. Hope I am connected. I am with you people. Hello. Yes, am I audible? Am I connected? I have lost the connection. I am asking.
Yes, sir. Audible, sir.
Audible and I am connected. No. So I said B, that is what output of the transport block with CRC addition. I denote as B, which is equal to A plus 24. Is that point is clear? I am asking. So for this, there is no answer.
Yes, sir.
What is A? I said A is the size of the transport block. So it may be having hundreds of bits. Okay. So that plus 24 bits, that will give you the output of the transport block with CRC bits. See, my dear students, please be attentive. Try to understand this. just for the sake of attendance, if you log in, if you start doing something else, then it won't help. Really, this understanding is not that easy to get from your prescribed textbook, what I can say. Okay, maybe you may read and vomit just for the sake of examination, but try to understand the concept. So that is why I wanted to be interactive. If you are not responding, then what I can understand? See why I should give this much of clarity and picture if you don't give any attention. So you want me to do just what is there in the text and say thank you? Yes, my dear friends, please talk. Are you really interested to understand these things? Hello, what is this, sir? Not at all talking. Are you really interested? Are you able to appreciate the concept of this? Hello?
Sir.
Yeah, is it okay? Or you want me to just throw as per text without giving this picture?
No, sir.
No means what, man? What I need to say or understand? So if I go as per the textbook, no, only blocks is there. This block. Okay. So if I don't want to say all those things, I can skip and go. Not an issue. Okay. If I get the response, then only I can proceed with this understanding. I feel it is necessary to get the visualization of all the steps, how things are done. Okay. I don't know how many of you are really involved and active. Only those will be able to understand and get the clarity. Okay. So if you don't respond, then my assumption will be that you are not active, you are doing something else only. You can do that something else. Yes, I understand, but not at the cost of understanding the subject. Yes, shall I proceed?
Yes, sir.
So at least B is equal to A plus 24, able to say that. I hope I understand. Okay. So then after CRC addition, the next block is what I said, that is the code block segmentation. Okay. So this code block segmentation is performed when the number of bits in the sequence after CRC attachment. So I called as B, right? So B is equal to A plus 24, I said, right? If the value of that B is larger than the maximum code block size. Okay, so what is that maximum code block size? For the turbo encoder, that the code block size is 6144 bits. Okay, so I denote that as Z, so which is equal to what? 6144. Okay, so I will be, as I said, doing the code block segmentation if the value of B is larger than the maximum code block size. Okay, I said for the turbo encoder, the maximum code block size is 6144 bits. Okay, so what I said, segmentation, it will be breaking the long sequence into C code blocks. That is why it's written code block 1 with CRC, then code block 2 with CRC, and so on up to code blocks is CRC, right? So it will break the long sequence into C code blocks, and it will add an additional 24-bit CRC sequence to each block. So we say mathematically that C code block will have the value of 1 if the output of the code block, that is transport block with CRC bit, is less than the maximum code block size. Okay. Otherwise, it will be by B divided by Z minus L. Okay. So B is what? A plus 24, and Z is this value 6144, and L is the number of CRC parity bits. Okay. So this is how we express mathematically. Hope. So just I'm saying that only with this understanding of picture. So what I said, yeah, able to see output of the transport block with CRC addition, I denoted as B, right? That B is equal to A plus 24. So this is what that B is equal to A plus 24. Then what is done with the code block segmentation with CRC attachment, I get the blocks like this. Okay, what is that block? See, that is why it's written here. 1, 2, up to R rows. Okay. Yes, 1 row, 2 row, 3 row, and so on up to R rows with CRC attachment. Okay, so one single sequence is splitted into R rows. Okay, so it is, that is what is known as the code block segmentation. Yes, able to visualize this picture? So it is splitting the big transport block into multiple small blocks and add another CRC to each of the splitted chunk. Okay, so why do we do this? Yes, why do we need to do that? I said no, if the size is larger than that, we are going to do like that, right? If the transport block size after adding CRC is greater than the maximum block code size, we are going to split the incoming transport block with CRC into R number of different code segments with CRC. Okay. Yeah. So the next step is, okay, as I was telling, after the code block segmentation, the channel coding is done. Okay, channel coding is done. So what are the different types of channel codings are used here? So in LTE, the channel encoders applied to the transport channels are two things. One is tail biting convolutional coding, and second one is the convolutional turbo coding. Okay, these are the two different types of channel coding techniques which are used in the LTE. Okay, one is tail biting, second one is convolutional turbo coding. Okay, tail biting, convolutional coding, second one is convolutional turbo coding. Okay, so just I have mentioned here with the table what are the different types of transport channels and what is the coding scheme used and what is the coding rate. Okay, so for downlink shared channel, paging channel, and multicast channel. Okay, for these three different transport channels, this is the coding scheme used. That is what turbo coding. What coding rate? 1/3. Okay, for the broadcast channel, the coding scheme used is tail biting convolutional coding. Okay, tail biting convolutional coding with a coding rate of 1/3. Okay, and along with the channel coding scheme, the coding rates for the downlink control information. I think even I have discussed about this, right? Downlink control information, CFI, and HI. That is. And what is the coding scheme for each of these control information used? So for DCI, tail biting convolutional coding is used with coding rate of 1/3, and for CFI, the type of coding scheme used is block coding with a coding rate of 1/16, right? And for HI, that is hybrid ARQ indicator, right? HI is, for that the coding scheme used is repetition coding with a coding rate of 1/3. Okay, means what I mean to say is, say for these channels, downlink shared channel, paging channel, and multicast channel, turbo coding is used with coding rate of 1/3. As it means for every 1 bit there will be 3 output bits. So with that, I think I would like to show this diagram as a thought. Means this is the what output of the channel coding. So what I get here, what is the input of the channel coding? That is the output of the code block segmentation. So it will be like this. R rows will be there, right? Means one single transport block with CRC attachment will be broken up into C code blocks, right, with CRC. So as I said, that is R rows I am getting. After channel coding, okay, so with the coding rate of 1/3 means for every 1 bit I will be getting 3 outputs, right? So this is what is written here. So 3 by R rows. Okay, for every one code block I will be getting 3 such blocks. Hope you are understanding. 1 power 0, 1 power 1, 1 power 2. This is for one block. For the first one, for the first code block, output of the channel coding will be 3 such blocks I get. So like that. That is what is written 3 by R rows. Okay. So the turbo coding, whatever is used here. So one input, 1 bit input scheme becomes will what? 3 bit outputs, right? Okay. So one input row will be able to generate 3 rows as outputs. That's what the meaning of this. Yes, my dear students, this point is clear. Hello. Yes, hello. Have you got this understanding? What is the code block segmentation output and what is the channel coding output? So channel coding output is what? For every one block, I get 3 blocks. Okay, for every one code block, I will be getting 3 code blocks. I said for every one input, 1 bit input, I will be getting the 3 output bits, right? So code word is 3. Okay, that is what 1/3 is the coding rate. That is the meaning. Okay, fine. The next is tail biting convolutional coding. Let us try to understand what it is. So I said this is what the type of coding used in the broadcast channel, and for other 3 transport channels, the type of coding scheme is used turbo coding, right? So what is tail biting convolutional coding is, here the convolutional encoder used in LTE with a rate of what? 1/3, and the length is restricted to 7. Okay, right, with a rate of 1/3 encoder with a constant length of 7. So the transmitted code blocks are of finite length, right? So the trellis termination must be performed at the end of each code block. So in order to restore the state of the encoder to the initial state for the next code block. So for that purpose, we do this. If the initial and the final states of the encoder are known, then lower block error rate can be achieved at the decoder using a Viterbi algorithm. Okay, so just let me say what is this tail biting convolutional encoder. Hope you are able to see this. This is the input sequence. Okay, CK. Then different delay elements will be there. So we say S0, S1, S2, S3, S4 and all. Hope you are able to get, say, DK. This is the output of the channel coding, right? So with the 3 bits, which is written in terms of octal. Okay. Yeah, so the most common approach, what I said, trellis termination, are the padding and tail biting. So in case of padding, what is done is at the end of the code block, they are padded with the zeros. Okay, means we are adding zeros. That will force the encoder to state 0 at the end of the code block. So which is the starting state for the next code block. The drawback of this system is it requires additional bandwidth, right? Because we are padding zeros, right? Because of that. Okay. I think, yeah. The most efficient method is our trellis termination. Okay. Is the tail biting. Tail biting rather than padding. Padding will be a drawback because it adds zeros, right? Padding with zeros that leads to bandwidth wastage. So because of that, trellis termination will be more efficient if you go for tail biting. So what is a tail biting? The information bits from the end of the code block are appended to the beginning of the code block. Means it is almost like a cyclic prefix. What we say, tail bits will be prefixed, right? In the same way. So once these appended bits are passed through the encoder, then it will ensure that the start and end states of the encoder are same. So here as given with the example what I said, no, CK, right? So where the value of K can vary from 0 to K minus 1, that is C0, C1 and so on to CK minus 1. These are the initial values to the shift register. Even the shift registers I said S0, S1 and so on, right? Then with the initial and final states of the shift register are the same, right? So the parity bits will be generated from the appended bits in the beginning of the code block are discarded and not used for the transmission. So this is how the tail biting looks like. Okay. So this is what the turbo encoder. Just you can have a look. I think, yeah, in what way this tail biting is efficient when compared to padding zeros or padding method I said here. So all the inputs are afforded the same amount of error protection. Therefore, so there is no code rate loss here, okay, compared to the zero padding. But the decoding algorithm is complicated. I think looking at the circuit diagram, you will be able to understand that. So that is what the cost which we need to pay. Okay, so till this I have discussed about the channel coding. So next one is the rate matching. Right, so rate matching in LTE performs interleaving. So again, we need to discuss what is interleaving and all. So that is the we will see that in the upcoming slides. Okay. The thing is, in your mind, it should be there. Rate matching performs interleaving. Okay, as well as repetition or puncturing in order to generate the transport block that fits the payload size determined by the modulation scheme and the number of resource blocks allocated for the transport block. Okay, so the transport block size depends on the number of resource blocks allocated and type of modulation scheme and as well as the type of coding scheme also. Okay, so this rate matching is defined for coded block and it consists of these three steps: interleaving, bit collection, and as well as bit selection. So let me try to make you understand with this example what is done in rate matching. So rate matching leads to interleaving. I said no, rate matching performs interleaving, right, and as well as repetition of puncturing. Okay, it's all done to fit the size of the payload. Okay, so hope you are clear with the output of the channel coding, right? For every one bit, I said 3 output blocks I get. That is 3 by R rows. That is the output of the channel coding. That will be given as input to the rate matching, right? So output of the rate matching gives only the R rows. Okay, here 3 by R rows are there now. So again, it will be clubbing these 3 rows into 1 row. Like that, I get only R rows as output of the rate matching. Okay, so rate matching, as I said, means the output of the channel coding means for turbo coding. I said 3 rows of output for each row of input, right? So in case of rate matching, it will be reverse. That is, each set of 3 rows of input stream becomes 1 row of bit stream. Okay, these 3 rows of bit stream becomes 1 row of bit stream. So that is what the rate matching will do. Okay, so then, okay, here the question is how do we do that, right? How do we convert that 3 rows, set of 3 rows into 1 row, right? So here, what are the methods? How do we do that? Is it by just concatenating the 3 rows into 1 long row, or is it a random matrix of the 3 rows, or is it by interleaving the 3 rows into 1? So the probable answer is, as I said, it does interleaving, right? So by doing interleaving, we do that. Okay. Yeah. So how the interleaving is done? Okay. So interleaving is performed in order to spread out the occurrence of the bursty errors across the code block, which will improve the overall performance of the decoder. Okay, so interleaving is performed separately for the systematic and as well as parity bits. So interleaving, bit collection and bit selection is there, right? So bit collection stage is required to place the systematic and parity bits in the right order as needed by the decoder, and also the bit selection is needed in order to repeat or puncture some of the parity bits to create the required payload. That is what the functionality of the interleaving. Yeah, in that again we do sub-block interleaving. I hope you will be able to appreciate this with this diagram. Okay, so code block means a systematic stream and as well as parity stream, as I said. Then we do the sub-block interleaving for each. Then bit collection is done. Hope you are understanding with the diagram. Then there will be bit selection. So this is what is done in the rate matching for coded transport block channels. Means we are converting 3 rows into a single row. Okay. Output of the channel coding will be what for every one input we get 3 output bits. So output of the rate matching for every 3 input bits I will get only 1 output bit. So in an layman understanding you can think like that. Okay, so the sub-block interleaving is performed independently for each bit stream. Okay, so that is done by block interleaver with inter-column permutations. Okay. So this inter-column permutation pattern are different for turbo coding and as well as convolutional coding. Then that bit collection is what it is an virtual circular buffer is formed by collecting bits from the interleaved streams. So the systematic bits are placed at the beginning, followed by bit interlacing of the two interleaved parity streams. So interleaving guarantees that an equal number of parity 1 and parity 2 bits are transmitted. So which is shown in the diagram. So parity stream 1 and parity stream 2. So equal number of parity stream 1 and parity stream 2 will be transmitted by having a interleaving. Okay, so that is what is shown here with to get a better clarity, right? So 3 lines is the what output of the channel coding, right? Those will be passed through sub-block interleaver. Hope with respect to this diagram you will be understanding sub-block interleaver, what is that? Then output of the sub-block interleaver is given to the bit collection, right? Bit collection. Then the output of the bit selection will be done. Okay, so bit selection and puncturing. So this is how the in-bit functionality is done. Okay, to convert 3 rows into 1 row. Yeah, I think already told about bit selection and bit collection. If you want, you can have a look about this. So what this bit selection will do? So it will select the output bit sequence, the sequence length, and as L should first be determined, which depends on number of allocated resource blocks, modulation scheme, and as well as the MIMO mode. Okay, the L bits are read from the virtual circular buffer. Then starting point of the bit selection depends on redundancy version of the current transmission, which is different for different retransmissions associated with the hybrid ARQ process. Okay, so this means that one hybrid ARQ transmission to the next, even though the number of bits L is same, the parity bits that are punctured or repeated can be different. Okay. With that, what I can say during bit selection, if the end of the buffer is reached, then reading continues by wrapping around to the beginning of the buffer. So with k input bits to the channel encoder, the effective coding rate will be what? K by L, which can achieve any continuum of coding rates. Okay. So after rate matching, the next block is what? Code block concatenation, right? Code block concatenation. Here, output of the rate matching, what I can say, 3 input rows will be converted into 1 single row, right? So now what is code block concatenation will do? It consists of sequentially concatenating the rate matching outputs for different code blocks. Okay, that is what the meaning of this concatenation. So forming the code word input to the modulation processing. So it needs only the turbo coding when the number of code blocks is larger than 1. So just to get an idea, it is shown with this diagram. So this is the output of the rate matching, right? I have R rows, right? Right. So each what it will do, that code block concatenation, it will be combining the multiple rows into one long bit stream. That's what the meaning of this is. Okay. So F0, F1, and so on up to Fg minus 1. So multiple rows are combined into a single row. So this is all about the channel coding processing. Okay. So if you have any questions, I think I'm open to hear. I made my best effort to make you understand these concepts. Now I'll be sharing the slides. You can have a look, try to understand. So it is interesting also. Okay, just have to spend time. So I think with this, let me stop this.